So a named tuple is nothing but it's a hybrid version between a tuple and a dictionary. Named tuple, the name itself indicates it's a kind of a tuple where you can name it, right? So what is this hybrid thing that it is achieving in between dictionary and a tuple? Before that, what is the need of having this named tuple in Python? So for example, I declare something called color and then color codes. Some 55, 155, 255. So this is nothing but a tuple. But if I declare it as a dictionary, I can clearly indicate key and a value, indicating that this is read. A user who did not develop this code can understand by running this code. But for if it is a tuple, it says color of 0 is equal to 55. That doesn't make any sense, right? So that's about that. If you use a dictionary, then it will make a sense. But again, performance perspective, if you're dealing with a large amount of data and a traversal, blah blah blah, again it affects what is the dictionary. So you get these two things. You don't have to be compromised when you're using named tuple. So just import from collections named tuple. So you declare a named tuple like this, just like the way you are declaring your frozen set. You say frozen set and then you declare the set, right? So like that, you declare a name tuple like this. So this is nothing but the name of the contents that you're passing on, and then these will be the keys. So for each color, I mean, the super entity will be this capital C, and the name of those keys will be this. When you declare something like this, color is equal to color of, in the sense named tuple of these values, these will be automatically assigned as key value pairs. And you can access color dot blue, in the sense color dot the third value of, I mean, the value of the third key, which is nothing but 255. So if you want to test it out, you can do this. So we got 255 here, right? So it means you can again declare something like this. Come on. Okay. So print color dot green, maybe. Got this, right? So this is one way of accessing key value pairs by making the data structure remain as a tuple. Clear, everyone? So how do you import that? It's from collections. And how do you name that? By using a keyword called name the tuple of. So this one has a different color now, indicating that it is a data structure. So if I say int, it has the same color as color has, right? So it says that it's a different data structure. So this is just a simple topic that you can make note of because it might get useful for you in interviews. As I have told you, you can just tell them where they are asking you some use cases to increase the performance of dictionary. What do you do? Or they'll give you a use case. So most of the times you're dealing with a lot of data, and then you want to rigorously make sure that you were mapping those elements, mapping in the sense key value pairs, but still you want to achieve a lot of performance while you're iterating it. So you cannot choose tuple, you cannot choose dictionary. So I would choose named tuple in that case. So if you say that, obviously this interviewer will not be expecting this answer because a lot of the people doesn't use it because not because it is bad, but because they are not exposed to this. So if you have this exposure, then some credits will be added to you as well, because you know something which interviewer doesn't know. So that's a good point. Okay. And we're done with the functions. I think we can enter into oops, maybe. Can we? Or did we miss any other topics? You are the one who has to tell that. Is that your answer now? So we are about to discuss something on, till now we discussed what to write in program, but now we need to discuss how to write a program. So there's a difference between what and how. So if you want to add two elements and move that code to production, if you say a plus b and taking a as 2 and b as 3, let's say, if you move this code to production, it's not like a production ready code. If you want to write this, you need to write like this in a definition or in the function summation, let's say a valid definition again, a comma b, and then in try logic, try this, print or make this result is equal to a plus b. I'm sure you should not be using a and b. The valid justifiable variables declared for a and b will be using those. So again, print result, print the summation of a and b is. So this is what you will write, except if you're not using any manual exceptions, which we'll discuss later. So this is what I could say as production ready program, but still, what I would do is now we'll execute this program. So the summation of a and b is 5. So this is a production ready program, I would say. So it will not break anywhere, it will not fail anywhere. Also, I would not suggest you to give these values here. The values are never to be exposed in the program. I use something called arg parser. So, and then I'll pass them as arguments. Or you might want to skip that if you don't know about much exposure about arg parser also. So you use something called argv of 0. For that you need to import OS module. We'll discuss about those later. So this is how you write a program. So we'll discuss about whatever we are using this in here. So first of all, we need to discuss about try exception logic. Right. So discuss about this one. So this is the entire syntax of try exception. After try, we get pass, and then there's something called except, and then there's something called exception as G. You can also put anything as yes or E or Q or whatever it is, but the standard is E. Always stick or adhere to the standards, and then raise an exception of your choice. Else, pass, finally pass. Pass is again just used to fulfill the syntax, just like that. So if you are prone to a breakage in code, for example, the best thing I can deal with all the time is, let's say, with open. Okay, we did not deal with the files yet, right? Okay, let's come back to this later. A is equal print A by B or 1 by 0. If you ask me to print this, it says a 0 division error, right? The exception settings are like this: break when the exception is thrown. So what you can do is, I mean, if you are writing a program to print A by B, in that case, what you can do is always include your logic in try, print A by B, except a 0 division error. We have come across 0 division error. And we are just manually catching that very customized exception. We're not bothered about the other exceptions because we are now pretty much sure that we do not get any of the other exceptions. But if we're trying to run the code now, did I declare the value of A and B? Okay, it's in debug mode. Okay, got it. So this is name error, right? Name error is an other exception that is to be handled now, right? So except name error, A is equal to 2, B is equal to 3. Print A is now declared, comma A. Sorry. So whenever you got this name error, sorry, my bad. Just a second, let me remove this. Okay. What happened to this? Name A is not defined. Name error, we are getting it again. Okay. Let me just declare A for now. We'll come back to this. B is equal to 0. This is still in debug mode. Okay, let me just try to shift this somewhere else. So this is what you get. Yep. No, there is some mistake there might be. I mean the spelling of name error or something. So A is equal to 2. So what happened now? Now A is declared, which means that doesn't have any meaning at all. No. A is not declared here. So that's why it came into this exception as E. But now what is the error? Unindented did not match that. Oh my gosh. Okay, this happens every time with the supply. So it went to this exception and then it defined A and then it printed out what the exception is. So what if I declare something like this? It says B is not declared now because A is declared now after the exception is entered. Are you following? Or confused? Did I confuse you guys?
Yeah, I'm like, it's not clear for me.
Okay, got it. So we are trying to execute some logic which is failing. So let's accept it. So whenever there is an exception, any kind of exception. So for example, print A. So it says there is an exception, but it will not break the script. You're not exited out of your script with an error, right? So whenever there is an exception, you came into here and execute this logic. Something like this. So some logic you're executing here in your exception whenever a condition is met, whenever an exception is met. So this is how you handle your exceptions. Otherwise, your script, if you not give anything, your script might have broken with some error, which is nothing but an exception. So this is a valid scenario where you wanted to print A by B, but still it is invalid logically. Syntactically, it is valid, but there is an exception case that it needs to be handled because 1 by 0 is infinity. So like that, there are a lot of exceptions available, inbuilt default exceptions that are available in the Python by default. You can just explore them over them. These available exceptions in Python docs. But for now, this is how you can break it. But if you want to, if you know exactly what exception may occur, for example, in this case, you'll get something called zero division error, right? So you can just stop this error from occurring. So now you'll get an error saying that A is not defined because it's not a zero division error, it's name error. So if you also catch that exception, we came across name error. If you do that, this is how you catch an exception manually. But still, if you got any other exception, for example, you did not catch your exception manually, but you did not expect also. So for that cases, still you don't want your script to be failed. So there's a default except print there is unexpected exception. So this is what you can, this is how you can catch. But still, if you want to know what that unexpected exception is, you can alias it to something. So this is the unexpected exception that you got. So basically the standard is making it as E. I hope you're following. Or do you want me to do class again? I just want to make sure you're on the line. Okay, fine. Let me start over again. Is it so? Do you need it? Hello?
I don't know. Check with others. I think I'm okay.
Who
Can
is
you
that?
please explain it one more time?
Yeah. So, uh, try has a block to try some logic to be executed. Your logic may be correct, but there might be a chance to get an exception. Simple case, what I have explained is print 1 by 0 or print some n. You try to print it, you will get an error, right? So n or name called n is not defined because we did not define a variable called n, but still we are printing it out. So it's a bug in production. Bug in production is not a small issue, right? You should not let your script fail with that syntactic or silly mistakes. So you need to catch those mistakes. You don't want your script to get failed, right? So what I will do is I put that in tried logic and I'll make that print n here. So you got name error now, right? So when you do this print n here, there is an exception or an error. That error's name is name error. Let me show it again. It's name error. N is not defined. This is how it comes into picture when you're dealing with a regular code in Python 2. So for example, I just declared nothing, but I'm running that one and you'll get the same error. It says name is not defined, right? The variable is not defined. I'm trying to print that. So I don't want the script to break like that. So for that, what I will use is except. And except what it will do is, you follow till now?
Yeah.
So except, then do this. There is an exception. So if you do this, yeah, it's because of this. If you do this, it says whatever you wanted to say. So this is one way of dealing with your errors. So if you really want to know what that exception is, then what I would do is I'll just say exception is an inbuilt library, another module if you have observed yesterday's classes manual exceptions, I used this one as well, like class error exception. This is what I used. So this is an inbuilt library which handles all the exceptions. So accept this exception as E, or you just say this. So you can print this, but this is a class item. So you need to alias it. Actually, I never tried that. I wanted to try it. So you'll get that whatever exception you are facing now. But still, if you want your logic to be continued, I mean, till now what we have discussed, if there is an error or a code breakage occurring in your code, you can handle it. So when you execute the code, it went till println, there is an exception. So all this logic is waste now, right? So because it may be dependent on term n, in that case you put your logic like this. But if your logic is still independent, so what you can do is you just cut it off, raise that exception, and then print it off here. Uh, so now this is another exception, this is another story. So I'll just print this one. So this logic which is not affected by n, I can keep it in this except, right? Is it clear?
Yeah.
Yeah.
I hope everybody understood it. Otherwise, I can focus on this again after we discuss with files. That will make it more easier for you, I think so, to understand. So the whole point is, whenever there is an exception, go to that exception and call out instead of throwing an error. So don't break the script like that. And then if you are having here, for example, you have two exceptions, right? And you don't want your some important logic is there and you don't want that logic to be affected by these exceptions. That needs to be executed for sure. So that kind of code, which is independent of all those exceptions and variables and stuff, you can write print I am important and needs to be executed. So save this and run. Even though you have n number of exceptions, you will have this finally statement executed. So for example, I just comment it out, save it, and run. It says n, name n is not defined. Okay, sorry, I commented out the wrong one. So now here there is a breakage that is happening here, and it enters into exception, enters this logic, and still enters this finally. Previously, when I uncommented this, there is a breakage that is happening. So it checks whether it is zero division error. No. So there is a default exception. Whatever the exception, it will catch. So it goes to this exception, performs this logic, but it will never go to this exception. See here, right? So now, if you, in whatever the code you declare in finally, no matter if it undergoes an exception or not, even though you comment this line, there is no exception that we are having now, but still it will go into finally block. Finally is a default block which gets executed irrespective of the exception or try block. Got that?
Yeah.
Yeah.
And we also have else block, which is unnecessarily an optional one. So it says like this: try logic. You implement it. I mean, cut your code into two pieces. One, which is prone to exception. Two, which never comes in exception. So, for example, print script started. It is never prone to exception. You cannot expect any exception, that you are sure. So, like that kind of a code, you can put it in else. So, but there's no necessary of it. It's an entirely optional thing. So you can also manually raise an exception, like if I is equal to 2, then raise this one, I equal to 2. So you got this now, right? What happened here? Can somebody help me understanding this?
So the condition is true, that's why it's not raising any exception.
It raised an exception. That's why you're seeing something called mango sarello. Why are you seeing mango sarello here?
Because it's in zero division error, we raise that exception.
So you can raise your exceptions anywhere in your logic.
Yeah.
So you can just name this and then it will be raised. We can use the raise keyword to raise an exception whenever the condition is met. That's one more thing I just wanted to call out. And again, if you want to do certain set of logic only when the condition is met here like this, so you can raise something called zero division error, and in this print 1 plus 2, let's say, this logic is executed. So you can just break your logic at your convenience, at your conditions or something like that. And one more thing is, if you're dealing with a well-established platform, you always will have this something like user-defined exceptions, which we defined earlier, right? So we'll declare something called error and then exception. This is a class object, and then we'll declare your own exceptions. So except one, this is called as inheritance, pass, except two, error, and pass, so that this will be part of the exception thing now, and they can be used as except one. So, and if you define some logic in here, you can use them as well. You can make it executable as well. We'll discuss those in OOPS concepts, but that's all for now about try exception logic. Yeah. And then, did we discuss about the LEGB rule?
No.
No.
So that's about variables again. Okay. So LEGB is a way of dealing with the variables inside Python, how a variable works in Python. So we call it as LEGB, which is nothing but local, enclosed, global, and built-in. Local variables are localized to the particular block or an indentation level. Enclosing variables are the variables that are nested. We will discuss enclosing in the end, but for now, local is something localized to that particular indentation or particular block. So if I'm living in Hyderabad, I'm a local element, and I'm living in Telangana if I'm living in Hyderabad. So for example, if I'm living in Telangana, all the districts of Telangana, for all the districts of Telangana, I'll be a localite. So if I'm, and this Hyderabad, which is inside Telangana, will be an enclosed scope for me. And Telangana will be a local scope for me. And India or the world maybe will be a global scope for me. And built-in scope is something which is, for example, Python does have the list of built-in variables packed inside it. So that is what a built-in is about. So for example, yeah, let me just have a walkthrough on theoretical concepts first, then you'll understand more. I declared x to something and then defined a function, which means I entered into another indentation level, right? And then I declared another x over there. So let me just do that. X is equal to, I'm just saying, outside of block. So def, let's say some dummy function. Let's say y is equal to 2, x is equal to 1. Print x. Print x. Dummy. So what will be the output here? Let me just make it very clear. This is print inside the function. This is print outside function of function call. So can you help me with the output? This is pretty much simple, right? It's like a multiple
Inside the function.
Well,
This is print inside the function. The output is.
that sounds weird because we have two different print statements here, right?
Yeah, but
So for example, if I have a Python script with print hi, sorry, like this, what will be the output? I mean, this alone is your Python script and you execute it. What will be the output?
hi.
What will be the output?
Hi. Hi.
Yeah, right? So because
Yeah.
there are two print statements.
Mhm.
So how many print statements are here?
There will be two print statements.
Two
Then
print statements.
So what will be the output?
the first one will be which is inside the dummy, and the second one will be which is outside the dummy as well, along with the x the outside of block, and then this is the print inside the block.
Mm-hmm. So what is the output now?
Maybe there will be an error.
No, it's gonna be this same one.
So this is what I'm speaking about.
X is a global variable, so if x is not defined under the function, it will take the global variable value.
Okay. So when Python comes across this Python print x, it will first search for L scope, and then searches for E scope, and then for G scope, and then for B scope. That is called LEGB. So it searched for L scope here. This is the localized environment for this x, right? So in this localized environment, it did not find x defined at all. So it will go for enclosed scope next, which it doesn't have any enclosed scope. So we'll discuss about what enclosed scope is in a couple of seconds. But once enclosed scope is absent, now it will go to global scope where it found an x. So then it took that x. That's what happened. But once it found x in its local scope, end of the story. It will not go to another scope. So
The enclosed scope is a variable defined under the main function or will be under the class?
That's a good question. But still, we got enter enclosed. What enclosed is? We'll see it. So that's about global and local scopes. And if I try to print y, what will happen?
That won't print anything.
Yeah, that won't print.
In the sense, it will say
Because y is not a global variable.
The variable is going to be error. Yeah, the variable is not defined.
why?
Because why we have not defined it, and print statement is outside the function, but inside the function that doesn't, like the outside print function is not gonna go for the y which is inside the function. It doesn't even know if there is a variable exist as y.
Yeah, because y is not a global variable. It's declared in the inside of the function.
Yeah, exactly. So whatever you both said is correct. Y is a localized one to this scope. There is no enclosed scope or global scope for this. So this global scope, whatever you are seeing level 0 is its local scope. And in built-in functions, there is nothing called Y. So in LEGB scopes, there is nothing called Y. So we got an error. So let me just go ahead and declare some example.
Is it a new function or function under a function?
What do you think it is?
It shows function inside a function.
Exactly.
So here y would be enclosed, which is like the main function will look for a variable, or you can say it's a parent function and a child function. So the parent function, if it doesn't get the variable inside that function, it will look for the it will look for the variable inside the child function. Is it like that? And that particular variable is called a enclosed scope. I mean that particular area.
Yeah. So exactly. So what will be the output here?
Okay, the first one print will be 4. This is my 4, and then
We did not call the function.
the next one will take the variable y2, the next print statement.
Because
Because the first function is it's taking y variable is already localized, so it will take the local variable as it exists. So and then when it comes to, and that function is done, and then the outside print statement is outside the inside function. I mean it's outside the child function. So then it will look for the variable in this local scope, which is the parent function, and then y variable is declared as 2.
Yeah, exactly. What is the comment this?
Now this will be the 4. I mean that is called the enclosed scope.
Exactly. Agreed, everyone? Any oppositions? Looks like I'm the only one who opposes it because it's an error. So this piece of code is equivalent to me writing a print statement of y here.
Okay, so
Right? So the thing is, whenever you declare a variable and start a function, it will act or it will live inside this function as well. But if you declare something in here, You come out of the function, it will die. No more leaves. That point should be very clear. So this y is declared inside a nested function. And then this is the enclosed scope for this one. So dummy is the enclosed scope for EX. So if you uncomment this and comment this, it now looks for the local scope, which is not existing at all. And then it looks for the enclosed scope, which is this one. If this is not there, it will then look for something called global scope.
Okay.
This is LGG and then built-ins. Got this right?
Right.
Any more confusions here? How is the class today? Is it a bit confusing a lot?
No.
All right.
No.
Yes.
It's like a little brainstorming, but it's good.
Okay.
Because I'm not from computer science background or anything, so for me, it's like after the class, I have to, I have noted down all the keywords, then I have to sit and read all those. Yeah, it takes time for me.
Okay, okay. If please go through that once, and if you don't understand, we can start. We can have a session again for this explicitly. For
Okay.
those who want to have the session again. But still, this is
Okay.
the concept which cannot be skipped. And
Okay.
why I'm not even from the computer background. I don't know computers too much. So with just practice, we'll get it.
Okay. Okay.
Hmm. Yeah. I think it's much of like we can stop this here because you're already looking confused for me. And we are done with our 1 hour session, I think so. Yeah. So if you have any doubts in this, you can just call out. Otherwise, I'll just have to tell some 2 or 3 sentences about this LEGB and I'll finish off. Yeah, I hope it is clear for you. But if you want to make a variable called x is equal to 1 to leave outside also, you can use this one. So if you're trying to print x, again, if you're confused, I'll stop it. It says invalid syntax. Let me just grab the syntax from here. So this is it. Now your x, which is declared as a global, will replace the x that has a global value. Even if you print outside, it will be like this. So I remove y here. You'll get an error here, right? So if I give y here and say global of y, it leaves everywhere in its global scope. But do not use this global keyword. Do not use it. That's it. So it's no one will use it for sure. 90%. Even out of my own experience, never I used this global keyword because it will change the standards, right? So you're playing with your language or coding as per you wish. You should not do that. But still, there is an option to do that. And there's another keyword called enclosed, which does the same thing, but it's not recommended for you to do that. And about built-in functions, can we continue? Fine then. We'll close it up after built-in functions. As you can see here, import built-ins. In this dir of built-ins. So these are all the built-in variables, which will be the last scope which Python searches. So you got this right. This built-in variable has some value, some justification inside Python. That's why you got, even though you did not declare what it is, you got the output.
When you use except that keyword, so with that you use this kind of built-in functions, right?
No, so built-in is nothing but, let me show you. So tuple, you saw this right? Some super you might not have seen. Some you saw
No,
this.
no. Yeah, I'm just talking about the error thing. I mean, exception comes when you don't wanna block your code and still execute it, even though there is an error. So those errors, like a name error, zero error, those errors are already built-in functions, right?
Yes. So this, if you see this, all these are like those.
Yeah.
And again, for some, if you declare a list, for example, if you say sum of you got this as 10, right? So this is a built-in variable which has some justification or a logic assigned to it in Python.
What is the purpose of using hash? I mean, not this hash, like the built-in function hash.
Built-in function hash. So
Yeah.
you mean the hash, this one, exclamation. Where did you see that?
It was in the directory that all the built-in functions, one of the function was hash.
Oh, HASH.
Yeah.
So this is again a module which is dependent on the data type which you declare. So hash might be mm, see, there is something called underscore underscore add underscore underscore, right? It has a different meaning for strings. It has a different meaning for integers. Like
Do
that.
we have any option to like show what this particular built-in function does? Kind of a definition of hash, any keyword like that which shows that what is the definition? Yeah, help maybe. Yeah.
So this is about hash.
Okay. Yeah, that's the help function. Okay, got it.
Yes. So two objects that compare equal must also have the same hash value, but the reverse is not necessarily true. So you can just always play with this. Help is something which helps you out with all the methods or built-ins available.
Yeah.
Any more doubts in the session? No. This session is so perfect that you don't have any doubts. Good.